Oh. Okay, so how far is the center of mass of the Earth-Moon system from the center of the Earth? And then we're given all the masses and everything. So we have our Earth, which has a mass of 5.98 times 10 to the 24 kilograms. We have a moon, which has a mass of 7.36 times 10 to the 22 kilograms. And we have the radius of the orbit, which is given as 3.84 times 10 to the 8 meters. And then it wants us to express the answer as a fraction of the Earth's radius. So first of all, our center of mass is just equal to the sum over our masses times the individual radii over the sum of our masses. Taking the Earth as our origin, or the center of the Earth as our origin, and placing all the mass there, we would have 5. We could have 5.98 times 10 to the 24 kilograms times 0 plus 7.36 times 10 to the 22 kilograms. I've just realized that I'm not going to be able to write that much, so I'm going to actually just erase this and shift it down. So 5.98, 10 to the 24, times 0 because it's at the origin, ten to the 22 kilograms times this 3.84 times 10 to the 8 meters. And then that's all divided by the sum of the masses, so 5.98 times 10 to the 24 plus 7.36 times 10 to the 22. And so we can run this through on our calculator. This term is obviously going to 0. And so our center of mass is equal to 4.669 times 10 to the 6 meters. Okay, and now for B here, the radius of Earth is 6.371 times 10 to the 6 meters. So our center of mass over the radius of Earth is 4.669 times 10 to the 6 over 6.371 times 10 to the 6, which comes out to be 0.733. So the center of mass is about 3/4 the radius of the Earth, or the center of mass of the Moon-Earth system is actually inside the Earth, because the Earth is so much more massive than the Moon. Okay, so let's check through the solutions here. Given our values, so we can solve for our center of mass, setting the Earth at the center. So it's just going to be 0 plus our moon distance and mass over the total mass, which that looks good. So about 4.67. So that looks good. And then taking the ratio, we get about 0.733, which looks good there too. So that looks correct.